Good day, class. We are Josephine Odesanya and Sumitha Kosanam, and we will be presenting a type of assistive technology known as the Sip&Puff. But before we go into the details, let's start with its origin. Sip&Puff switching began not as a product, but as a solution to help one person communicate. In the early 1980s, Neil Squire, shown in the middle of the screen, a young man who became quadriplegic after a car accident, was unable to speak or move his hands and arms. A team of engineers and researchers began experimenting with ways he could interact with a computer. They discovered that Neil still had breath control, so they built the first sip and puff communication system. By inhaling and exhaling into a tube, Neil could type letters on a screen. This project eventually led to the formation of the Neil Squire Society, a Canadian organization dedicated to accessible technology and digital independence. Their early work laid the foundation for modern SIP and PUF devices used today in mobility, communication, and environmental control. On the screen right now, on the left and the right, you can see Neil in his wheelchair using the Sip and Puff. And there is a link to the accessible timeline of the Neil Squire Society below. So, Sip and Puff started as a one off engineering solution and has grown into a standard assistive technology that gives people more control. Who uses it today? Sip and Puff is useful for individuals with spinal cord injuries, neuromuscular disorders, cerebral palsy, and multiple sclerosis, limited or no arm or hand movement. Sip and Puff switches are used anywhere a button press or joystick movement is needed. The most well-known application is driving powered wheelchairs, which my partner Samitha will cover in detail later. But the applications are much broader. It can be used for computer access, navigating a mouse, clicking buttons, typing, or scanning through on-screen menus. It can be used as AAC devices, communicating through speech-generating devices using SIP and PUF scanning. It can be used for smart home control, turning lights and TVs on or off using Alexa or Google Home through SIP and PUF compatible hubs. In all these cases, a simple breath becomes a digital command. What is powerful is not the hardware, it is the independence it enables. Sip and Puff turns breath into autonomy. And now we will go over into how it works.
Let's talk about how Sip&Puff works and the technology behind Sip&Puff. Here are a couple of pictures to show what the Sip&Puff device looks like. The back and side cushions you see go around the head and are used to keep the device in place comfortably. There's an adjustable tube to the mouthpiece, and this tube can be moved or cut to fit the user as needed. The diagram here shows the components of the Sip&Puff technology. You can see the mouthpiece that goes up to the user's mouth, the pressure sensors and the air sensors connecting to the tube, the control unit, and the sensing unit. Here's the high-level process of the Sip&Puff device. The pressure sensor is used to gauge the air pressure. Sipping or inhaling decreases pressure, while puffing or exhaling increases pressure. The pressure levels are then translated into electrical signals. And finally, the electrical signals are sent to the connected device and are used to control it. This device can be something like a wheelchair, a computer, or anything else. Sips and puffs can either be considered hard or soft. This is depending on the pressure change that the breathing causes. The setting is usually initially calibrated based on the user, as each user may have different breathing abilities. By evaluating the difference between hard and soft sips and puffs, the user is granted even more controls that they can access through their breathing alone.
On to the manufacturers and fabrication differences. There are several manufacturers that make sip and puff systems, and while they all look similar from the outside, how they function internally can be very different. For example, in the table on the slide, Origin Instruments, the Sip and Puff Breeze, focuses on clinical reliability. Their devices use medical grade pressure sensors and are designed for durability and wheelchair integration. The Tekla E focuses on digital access. It connects Sip and Puff inputs to smartphones, tablets, and even smart home assistants like Alexa. Joust or Quadjoy combines Sip and Puff with a joystick, letting users control a mouse cursor or gaming setup. AbleNet creates classroom-friendly models that are simple switch interfaces. Where they differ most is in the fabrication approach. We have the sensor type. Some use analog pressure transducers that require calibration, maybe mouthpiece design. Higher end systems use disposable grade tubing for hygiene, while DIY systems may use hobby tubing or 3D printed mouthpieces. We even have a approach in the output method and adjustability. Commercial devices can cost anywhere from $300 to over $2,000. Some open source and DIY options, like LipSync from Makers Making Change, allow people to build a functional sip and puff system for under $60. The main difference comes down to clinical durability versus affordable accessibility. And now my partner Samita will go over a specific application of Sip and Puff, which is for wheelchair.
One application for Sip&Puff that we'll focus on today is Sip&Puff for navigation in the form of wheelchairs. Here you can see how Sip&Puff technology is integrated into wheelchairs, connected to the top of the wheelchair and adjusted onto the user's head with the mouthpiece by the mouth. This technology in wheelchairs allows the user to control the movement of the wheelchair while being completely hands-free, using only their breathing instead. This is extremely helpful for people with disabilities that cause them to be unable to use not only their legs, but also their arms or even their voice. This technology provides them with some form of independence and autonomy, at least when it comes to their own movement. And here's an outline on the basic controls when using Sip&Puff with a wheelchair. An initial hard puff will enable the wheelchair to move forward, while a subsequent hard sip will stop the wheelchair. On the other hand, if we begin with an initial hard sip, that will enable the wheelchair to move backward, while a subsequent hard puff at that point will stop the wheelchair. A continuous soft sip or soft puff enables the wheelchair to move left or right respectively, depending on how long the user blows into the tube.
About how Sip and Puff works, we are going to simulate it. Each team will get a cotton ball and a smooth surface. Your goal is simple. Use only your breath to move the cotton ball from one end of the table to the other. No hands, no touching, only controlled bursts of air. As you do this, notice a few things. How much control does it take to go in the right direction? How quickly do you run out of breath? How hard is precision, not just movement? And please note these reflections in the next slide. You can copy and paste to write down each team's reflections. For Sip and Puff users, this level of precision is required every time they want to click, type, or drive their wheelchair. It gives us perspective. What seems small, a sip or puff, is actually a skilled, intentional act. Thank you. Please gather and start the game.